Let's talk through the basic workflow of Mantis Rigging Nodes. First thing we're going to need to do is install the add-on. So if you go to Edit, Preferences, and then go to Get Extensions, up in the top right corner there will be a Repositories tab. Add a new remote repository. For the URL, we're going to go with https://nodes.tools/extensions. And let's go ahead and check for updates, since I have been updating it a lot lately with bug fixes, and hopefully I'll be able to add some new features soon. Go ahead and install it. And if there's ever a problem when you install it, it's probably because I'm updating it. So just try again in a few minutes and it should work. So what is Mantis Rigging Nodes? From a broad perspective, I like to think about it as if we are in a restaurant. And these are our animators. They're the customers at the restaurant. And they're not really sure what they want, but they have a general idea. You know, this guy likes pasta. Maybe she likes salad or something. So they ask you a few questions about the different options and they give you a general idea of what they want, but they're not 100% sure because they haven't actually tried to eat the food yet, or, as the case may be, animate the scene. So they ask you to give you what they want, and you write it down on your note card, and you take it into the kitchen, you follow a recipe, you cook it up, and make yourself a nice high-quality rig. You bring it to the animators, and they sit down and they try to animate the scene, and they're like, oh my gosh, this isn't what I wanted, please take it back. So you take it back to the kitchen, you break out your recipe book and follow the recipes one by one, and you cook up a nice high-quality rig, and you bring it back to the animators, and maybe this time they're happy. Maybe they're not. And you might have to go through that process several times. And the part as a rigger that makes that really hard is maybe you've got a whole bunch of solutions that you know of, that you've got planned, but the part where you have to go into the kitchen, follow the recipe, and cook it up every time can be really time consuming because you're having to do stuff by hand, or you're having to use a Python script that you have to then edit and update after the fact by hand, or you're having to write a Python script. The idea behind Mantis is to give the waiter the right to be just a waiter, and to let the chef do just the chef work. And you're the rigger, you're the waiter. You don't care about how the rig is made. You only care about what it is, and you care about delivering it to your animators so that they can have a nice, high-quality animated scene. Everything here in terms of the chef stuff does not matter to you. So the way Mantis works is you write down what you want in the form of a node graph. You hand it to Mantis. Mantis uses this recipe book right here to generate the rig according to all of this complex Python code that I've written that tells it exactly how to do it. And then you get your rig, you hand it to your animators, they ask you for an update, you give it back to Mantis, and you can iterate just like that until your animators are nice and happy. Now, the reason why it works like this is because Mantis uses a declarative syntax. So if we take a look at one of these components, it can be a little confusing at first. Just give it time. You'll be able to read it easily before long. But if you look at each individual node, they all tell Mantis what you want. I want a bone. I want this bone to have a child, which is this other bone. I want the name to be set according to such and such parameters. I want you to place it in such and such place. I want you to give it such and such a custom object. I want the bone to have a copy transforms constraint called fk and a copy transforms constraint called ik. I want the bone to be hidden. I want the bone to have a stretch to constraint. So all of this stuff is just telling it what you want. And that's hard enough because designing a rig involves a whole lot of these complex connections between parts. And you've got a bone, you've got different parent-child relationships, you've got different constraints. You've got to figure out exactly what each constraint is supposed to be doing in context of the deformation or the control. That's hard enough, right? So if you let Mantis do all of the doing, then all you have to worry about is what you want. And that way you can continue to iterate quickly and have happy animators.
Do you always look at it?
Nodes.
Well, you have to. The image translators work for the
node graph
program. You get used to it. I don't even see the
nodes.
All I see is
constraint, bone, driver.
Alright, now let's get to the practical part of this demonstration. So the first thing we're going to want to do is make a new panel. So click and drag from the corner, and under this editor type dropdown, pick rigging nodes, and we'll add a new graph, and we can call it whatever we want to. And the first node we want to create is under transform armature, an armature node. We're going to call this one, I guess, cats is a fine name. And you'll notice that nothing has changed in our 3D viewport, but a new object has appeared in our outliner. If we go into edit mode, we can see that there are no bones in this armature because we haven't defined any yet. So it's just an object object with no data associated with it. If we want to add some data to this object, we can go to transform bone by pressing Shift A, and then we want to drag from the orange xform out. Xform is short for transform. We want to drag xform out into relationship on the bone. And we'll call this one calico. And now when we press E to generate the graph, you can see that there is a bone. And if we go into edit mode, we can see that this bone is in fact called calico. It's also there in the outliner. If we want to add another bone, we can just do the same thing, transform out into relationship in, and we'll call this one Persian. You'll notice that there's this relationship line now. This Persian bone is a child of the calico bone. You'll notice that the transforms are automatically locked on the bone. Unlock them by clicking on the locks at the bottom of the node and dragging your mouse. You might be wondering why I have the transforms locked by default, and the reason for that is very simple. In a rig, you have a few control bones, but you have lots of mechanism bones. Or, a lot of mechanism bones that control how the control bones affect the way the rig is posed. Your rig is your first and most important tool of communication to your animator. And you can communicate to the animator the stuff that you expect them to animate by setting the locks. So if I don't expect this bone right here to ever have any scale applied, I can lock the scale, and now the animator knows that the scale on this bone doesn't do anything helpful. Similarly, I can lock the location, and now the animator will get a rotation command even if he presses the G key to grab it. And even the move tool will do the same thing. So for now, we default to locking the controls as a way to encourage you to have good practice as a rigger. During these tutorials, we're going to be talking a lot about good practice, because rigs are a lot more than just bones and constraints. They're a way to communicate with other human beings, and ultimately to create expressive characters. So we're going to be keeping that in mind as we work. So our rig right now has 2 bones, and if we press E to generate the graph, we can see that Mantis remembers the pose, which is very helpful. But let's clear that and see where the bones go. And you can see that the place where they live is right in the center in the default position. So we'd like to be able to change that. How do we do it? We need to plug something into this matrix input. Now what is a matrix? Well, you can see here it's just a box full of numbers going up and down and left and right. And if we try to edit it ourselves, we can see how confusing it is for a person to use. So because only the computer knows how to interpret or edit these numbers in the matrix, I've added some human-friendly tools, and there's a whole bunch of them, but the one we're interested in right now is the MetaRig node. I've already gone ahead and created a MetaRig for the demonstration, but I'll go ahead and make another one to show you how it's done. So first you create an armature object from a single bone, and then you just place the bones however you want them to be placed, and name them whatever the appropriate name is. Press F2 to rename a bone, by the way. That's really helpful. I like to, when I have a MetaRig object like this, I like to go down into the Data tab in the Properties panel and enable showing the names and the axes, and I also like to set them to display as a stick. Let's go ahead and call this object leg, and thigh, and shin. And one of the things you'll notice is that this cat's object hasn't gone away. And that's just because I don't want Mantis to go around deleting your objects. Objects are anything in the outliner that has an orange icon here. The green icons are data, and it will delete and modify the armature data, the bones and stuff, since that's the whole point, is editing that, right? But it won't delete your objects, which is, it's intended to be a safety feature. Anyhow, let's go ahead and delete the cat's object ourselves. You'll notice that this isn't generating, it's just because I have this MetaRig node, but I don't have an object selected. So let's select MetaRig, plug that in there, and you can see now that that bone is going to the location of this MetaRig object. We can also go ahead and select a bone, and you'll notice, by the way, that there's a drop-down menu that helps you select it. That's nice, isn't it? Anyhow, the bone ends up in the location of the MetaRig relative to its own origin, and the armature, if we want it to show up where the MetaRig is, we can just use the MetaRig without any bone selected. Because if we select a bone, it'll do something silly like that. I kind of like having it generate to the side so that I can read the MetaRig and the rig that I'm editing. So you can see that it's not very hard to place bones where you want them if you just use a MetaRig. The other cool thing about this is that we can just switch to a different MetaRig if we want to. So you can see now it's following the shape of this one, and I'll name this one Meta 2. And you can also see that this will update automatically when you rename the MetaRig object. So yeah, try to make it easy to use. And in fact, if you want to, you could make a string input. So press Shift A, go to Input, and pick String. And we can just name the MetaRig, and we'll plug this into that input. And you can see it still works. And we can also call this one Meta 2. And it will use the Meta 2. And of course, the same thing works for the bone input. So if we just make a thigh string and plug it in there, and there, Change that to shin. You can see the bone moving up and down. So this is where the fact that it's a node graph starts to feel like you've got some real power, because by changing the inputs to these meta rig nodes, you can dramatically change the way the rig ends up being shaped, but the behavior of the rig stays the same. Anyhow, let's go ahead and make another bone for the foot. Let's press E to generate the graph, and oh my gosh, look at that, there's a problem. You can read right here in the error message that it gives you, could not create bone, shin, perhaps there's a duplicate bone name in the node tree. And you'll see there is a duplicate name. Go ahead and try to generate this, and you'll see it leaves you in edit mode. And if you try to move it around, there's this bone that appears out of nowhere called shin.001. And that's because when you generate a bone with an identical name, it can't add it to the armature and it has to change its name. I'll show you. Press Shift D to duplicate this, and you can see it's named shin.001. So you can't have two bones with the same name in an armature. You just can't do it, no matter what. Obviously, I have to follow that in Mantis, and instead of just renaming stuff automatically because that's what Blender does, I'm enforcing the fact that you really ought to always name your bones. Because if you don't name them, you end up with a rig that's really hard to understand, not only for the animator, but for you, and there's just never a good time to not be careful about your names. I'm enforcing good practice here by doing that. Now we have our three bones. For this sort of thing, I also like to add a parent bone up at the top, drag the transform out from our armature into the relationship in of the bone, and do the same thing from bone to bone, from this new parent bone to the thigh bone. And now press E to generate, and you can see that the thigh is a child of the parent bone. We've got our four bones here, and we've unlocked the transform so that we can play with them. Eventually, when we give this to the animator, we're going to want to lock all this again, because the animator really shouldn't be messing with the bones that are not animation controls. Anyhow, the next thing we need to talk about is what's going on right here. So you'll notice there's a connection between the transform nodes here that are orange that changes in color from an orange socket to a green socket. And you might see that and intuitively know that there's something a little wrong there. And that's because what's happening is that Mantis is implicitly creating a node between them, an inherit node. When I generate the rig here, you'll notice something has changed and that the foot no longer inherits its rotation, because this inherit node gave us some new settings that we can use to control the parenting between these two bones. You might wonder why I've chosen to make this a separate node rather than a property of the bone node. Since if you go into the properties panel, you can see that all the parenting settings is controlled on a property of the bone in the relation tab. But the name of this tab right here tells you all you need to know. It's a relationship between this parent bone and this child bone. This stuff doesn't control this bone, it controls the way this bone relates to this bone. So it's a separate node in Mantis, because it is, after all, a relationship. And that's why it's also the first node in every relationship chain of nodes. So you'll notice now it goes from green to green and from orange to orange. And it's safe at this point to start adding constraints if we want to. So, we can make the foot, if for some reason, if we wanted to do this, we can make the foot follow the thigh bone somewhere in the middle. And you can see that it actually updates live sometimes. And you can see the foot is still following the shin's rotation, but it's copying its location from the thigh there, because we added this copy location link in the chain. I call them links. They're constraints. Maybe I should just rename that. I call them links because I just want to make it very clear that what they are is a relationship between different objects and bones and stuff. So they're a way to link bones together. But what they are is essentially the same thing as our Blender constraints. So you can see that the interface of the node is almost the same thing as the interface of the constraint. The only big difference is that instead of being able to select our target by name, we plug in a transform from another node. So you see this thigh bone has its transform out going into the target of this copy location node. It can be a little bit confusing at first when you see these node trees, but once you understand what these connections mean, it's really straightforward, and it's easy to pick up and understand. The other thing you'll notice is that it has its head-tail switch, and it has the use b-bone switch, which is this and this. I don't think in the node system it really makes sense to try to combine two different settings into one section like this, especially since they're, one of them is a number and the other one is an on or off switch. So they're separate connections in the node. We have our axes, we have our invert axes, we have offset, and then we have the space and the influence. So you'll also notice when you add a bone constraint from the menu here that there are 3 different categories, and there's these weird ones that no one ever uses. Transform, tracking, and relationship. You'll notice that we have the same categories here: transform, tracking, inherit. You'll also notice that they have different colors. So our transform constraints have this green color that's the same as the relationship socket. Our inverse kinematics constraints have a yellow color, which is the same as the, if we just add an IK constraint, you can see it's got this yellow color. Once it's, once it's working, it's got this yellow color. So the node is yellow, and then these tracking style constraints have a blue color. So everything's color coded so that you can kind of tell what's going on at a glance. So what we want to do here then is just make a basic IK chain. Let's go ahead and make these bones. Let's go into pose mode and then Alt G, Alt R, Alt S with everything selected to make them go back to their default 001 thing. And let's go ahead and duplicate this inherit node. And you can place one between the armature and the bone also. And it doesn't have any settings because the bone doesn't really have any meaningful settings when it's the first bone in the tree. And I think what I want to do is I want to have these bones be connected to their parents. And now when we try to generate the tree, there's a problem. Oh my gosh. What does it say? It says could not create edit bone thigh because bone head was located in the same place as bone tail. Then there's some garbage at the beginning and end because if we look in our terminal, it's printing it in color. That's really helpful for me as a developer. I'm not sure that it's helpful within Blender because it adds this garbage in the beginning and end of the error message, but you can still read it, right? What does this mean? Thigh. It can't create edit bone thigh because bone head was located in the same place as bone tail. Well, if we go into our edit mode and press G, we can see that the thigh bone it's trying to create has a length of, well, when the tail is in the same place as the head, it has a length of 0. And Blender doesn't like that, so it will fail when we try to do this. The reason why it's giving it a length of 0 is because it's a connected bone. The meta-rig thigh bone right there wants to place the tail at this knee joint, but since it's connected to a bone that has the same shape, it ends up placing the tail in the same place as the head, and then it fails. So we just need to make the thigh not be connected to the parent, and now it will generate. So we have our bones now. Let's go ahead and make this into a basic IK chain. And in order to do that, we're going to make a tracking link called inverse kinematics. And this should go into the shin bone right here. So just drop it between the inherit and the shin bone. We need the foot to be the target. So the foot really can't be a child of the shin bone. And in fact, if we try to make it the target, we'll see there's an invalid link and it won't generate. And if we try to generate it, it says there is a cycle somewhere in the graph. That's because a child of a bone is trying to affect its own parent. You can see that this socket link thing is going backwards in the tree. That's messed up. We can't do that. What we have to do is we have to make this a child of something else. So let's go ahead and make it a child of this overall parent that I created earlier. And now we can make it the target of our inverse kinematics constraint. Let's press E to generate the graph, and you can see it's not doing anything. And that's because we haven't set any of this stuff up. So let's go ahead and over here, let's just figure out what it is we want it to do. Well, we better turn on the influence, right? And we need to turn on position. And now it's working. By the way, if we have the chain length set to 0, you can see that it's 0 uses all bones. See that? So we don't want that. We need to make sure we set that to 2. So let's go ahead and do that in our node over here. 2, set the position to 1. We want to use tail, and we want to set the influence to 1. You might be wondering why this isn't set up automatically for you, and it's another case of that adds a lot of work to development to add default settings, and I just haven't done it yet, but I will do that in the future. Anyways, you can see that our IK works just fine now. And if we want to make this switchable, what we can do is we can duplicate these bones, and let's go ahead and name them, differently so that Mantis will generate the graph, because it won't generate the graph when the bones are the same names as each other, as you can see here. So we'll call this one switch, and we'll do the same thing here, switch shin, and we'll call this one switch foot. And there's something a little bit weird happening here because our thigh bone does not have its meta rig. Let's go ahead and add that. Easy, easy. Now we can move the IK chain around and our switch chain stays where it is. In order to make the switch chain follow the IK chain, what we can do is we can add a new constraint up here. By the way, we can use the reroute nodes however we want to organize our graph, but for some reason I just can't get it to have the right colors, so it's just always yellow for some reason. I'll figure that out in time, but we want to add a copy under link transform. We want to add a copy transform constraint, and we'll make one for each of the bones in the switch tree. We will set the influence all the way to 1. Everything else is fine. You can see this menu right here gives you a whole bunch of different options for how to copy the transforms. You just have to make the node wider so you can read it. And obviously we're going to need to add targets for those. So this one is going into the thigh. So we'll take the IK thigh as the target. This one is going into the shin, so we'll take the IK shin as our target. And this one is going into the foot, so we'll take the IK foot as our target. At this point, maybe it's starting to get confusing. So what we can do is we can select these IK nodes and press Ctrl J, create a frame, and we'll call this IK. We can go ahead and give it a color. If we go to the N panel and click on the Node tab, and let's make it like a pale yellow. And then over here, we can call this one Switch. And of course, at the current point in time, our switch is turned on all the time. Now that's not very helpful. So let's go ahead and add a new custom property to our parent, and we'll use a float because we want to be able to slide it back and forth from 0 to 1. And we'll call this one FKIK. And we can describe it as whether we use K or IK. You can see that it added an edit and a remove custom property button on the node itself. It also added some inputs and outputs for the custom property. Let's use the custom property to create a driver that controls whether the switch is active or not. In order to do that, we can press Shift A, and then under driver, we can add a switch node. Let's plug the FKIK into the parameter input on the switch. And then this parameter index thing is only valid if the custom parameter is a vector and it has an X, Y, and a Z component. So we can leave that at 0. And let's go ahead and plug the driver directly into the influence on the constraint. Now you can see in our generated graph that the switch is an FK chain that doesn't copy IK chain at all. But if we select our parent and then under its custom properties, we look at the FKIK, we can slide it back and forth. Very nice. We've just created a driver for 3 different bones with a single node simply by dragging and dropping connections between the nodes. This is a really awesome feature of Mantis because oftentimes you'll be designing a rig and you want one driver to control a whole bunch of different things. And it's just such a pain to edit them one at a time. I have in production written Python scripts to add the drivers and edit them. And that's actually really hard to do. I'll show you the file that I have here in my add-on where I do it. And you can see there's a whole lot of complicated stuff here that goes into making a driver from a generic template. You don't want to have to deal with that, right? So the best way to do that is to just use nodes to do it. That way you don't have to write Python scripts. You don't have to go through the interface copying and pasting drivers and stuff. This is one of my favorite features of Mantis, considering all the pain I've gone through in the past dealing with this process. Anyhow, we've got our FKIK switch, and obviously in a real rig you would probably make a separate FK chain and then have a switch that just switches between them, but this is okay for now. We're trying to keep it simple. So at this point, we have a functioning IKFK leg. Let's go ahead and make it look a little bit nicer by adding some custom shapes. And I'll go ahead and add a mesh circle, and I'll call it circle. That's good. I'll add a sphere, and sphere is good. And I'm going to duplicate this circle. Then I'm going to make a simple gear-shaped controller. Press 2 to enter edge selection mode, select one edge, then select all edges. And then you want to search by pressing F3 for checker deselect. And now you can see it's selecting every other edge. At this point, press E and press S. And now the annoying thing is selecting these edges that it left behind, which I think you have to just do by hand. And then just delete the edges. And now we've got a gear, we'll call it gear. And now that we've got our custom shapes, we'll move them into a new widgets collection. And we don't need to see that, so we can hide it. Let's add them to our rig. So go ahead and search for existing object, or press Shift A and click input, existing object. Either one works. For our IK chain, let's just use the sphere as a custom object for the foot. Let's have it scale to the length of the bone and use a wireframe. And it's still way too big. So down here we can make it, we can affect the custom scale, the custom translation, and the custom rotation. So let's go ahead and set the scale to 0.1 on each axis, and that is a lot more reasonable. A little bit too small. And you know what? I think I'd like to make it so that we can see what shape the foot is. So I'm going to go ahead and
edit this object and just add cube to it, and I'll start to
it's a little bit silly and ugly, but it doesn't really matter. The point is that we can make a custom shape quite easily, and we can edit its transforms We don't need custom shapes for the other bones in the IK chain. But for the FK chain, we want to add existing object. We'll choose circle, and we'll plug that into custom object. You can see that it will only expose the attributes for the custom object once we have something plugged in there, by the way. That's nice, isn't it? Let's choose custom object scale to bone length. And again, we'll set the size to something reasonable. And we'll just do it again for each node. Very nice. Now for the parent, let's go ahead and use that gear that we created. And it's kind of too big. Let's make it a little bigger than that. And let's rotate it so that it is kind of following the bone shape. Looks like that's the right axis to use. So now we can clearly see when we look at the rig what each bone does because of our custom shapes. Very nice. Now there's one more thing I want to do here, which is to package this into a reusable node group that I can use on a character with as many or as few legs as I have. Let's go ahead and select these guys. I want this to have an output, so I'm just going to go ahead and add an inherit node here at the end to trick it into giving us an output. So I'll select everything but the armature node and this inherit node at the end, and press Ctrl G. And now the node group has an input and an output. So if we press tab into our node group, you can see it's the thing that we just made. And things might have got moved around a little bit. It's automatically created an output and an input. So what we want to do is we want to give this node graph a way of telling whether it's the right or the left side. Because as it is, it's just a single-legged creature, which is kind of, maybe you created something like that in Spore before, but probably haven't created something like that in real life. So I'm going to go ahead and edit our meta rig. I'm going to move it over to its left, which is my right. Then I'm going to go ahead and press W to enter my armature menu. Or if you're using left-click select, you can just right-click. And now under the name sub-menu, click auto name left-right, and you can see what it does there. Now, we don't want to shift D and then just place it because that will add the numbers at the ends of the names. What we can do is we can select all these bones and we can enter our armature menu again and symmetrize. And then it will automatically set the right and left. But we will go ahead and duplicate that a couple of times to make a meta rig with lots and lots of different legs. And the names are starting to get annoying, so I'm going to hide them. Now, if we try to generate this graph, it will fail because our meta rigs that we have in there are asking for the bone without its .left.right thing. So what we can do is we can add a node, which is called concatenate strings. And we can take this thigh, and then we can add a .l to the end. And plug that in there. And then we'll do the same thing for the name of the bone. Switch thigh.l, plug that in there. And now we're going to do that for each of our bones. And that should be all of them. And since it's generating correctly, we can see that it is, in fact, all of them. And you know what? I just noticed this circle is rotated all wrong. I'll just edit the circle real quick and fix that. So yeah, we can see that it is now generating correctly. And our switch works just like it did before. And it's going to use the left leg on this meta rig. You can see that it's on the left side of the meta rig there. See? So what we want to do is we want to add an input to the group that is the identifier for which side of the rig it's using. I call that a chiral ID because it tells us which side of the rig we're selecting, which is like left and right hand, which is called chirality in like, I don't know, chemistry or something. So let's just go ahead and duplicate this group input node a bunch of times and just plug the chiral ID into any of the places where we added a .l. That should do it. Oh, so when we press E to execute, you'll notice it's complaining. And that's because if we go out of our node group, it doesn't have anything. So it will have a problem until you add some text there. But you'll notice that we can use this text to select the left and right side. And even better, we can use this text to create as many legs as we want. Very cool. And this is it's just looking things up by name, right? So here in our meta rig, you notice that it's got the thigh.r.001.002.003. We can use this to make a creature with many legs, and as long as every bone ends up having a unique name, Mantis will generate it just fine and it won't complain about it. And as you can see, it works very quickly. What's the big idea of all this? That was it wasn't a huge amount of work, but it was kind of a lot of work in order to make this the first time. But now that we've made it, we can reuse it again and again and again and again forever. In fact, let's go ahead and call this one simple IK leg, and we can save this file. And whenever we want to use this component, we can just go into our Blender file append and go in here, and obviously we're in that file. But if I open a new file and I want to append that graph, I go to the file name and I click on node tree and I grab simple IK leg, and it brings in the objects that I need automatically. That's nice. And if I go and create a new rigging nodes graph and a new object, or a new graph name, and I can go to groups, node group, pick simple IK leg, and I need to make an armature node. Call this one legs, and then just enter the chirality and press E. So the idea behind Mantis isn't necessarily to make it easy to do the first time. It's about making it easy to do a second time, a third time, and a fourth time, and a fifth time, and an infinity number of times. So the real benefit that you get from using this way of rigging is not the first time you use it, but every subsequent time that you use it, and you start to build your own library of these reusable pieces. You can have whatever outputs and whatever inputs you want, so that you can build a kind of a complex system of interconnected parts. And as a rigging artist, you don't necessarily need to know how all these individual node groups work, as long as they work, and you can just keep reusing them. So we are going to be building a collection of these reusable components over the course of these tutorials for the next several months or whatever. But you could also just go ahead and buy my component pack on Gumroad. I'll show you that. Nodes.tools. Support me on locals. Look at that. Look at this nice situation we got here. If you support me on locals, you'll get Tree Hive assets. The first 50 supporters on locals will get the component pack, and you'll also be able to interact with me directly and get all kinds of feedback and help with your rigs. I'd really like it if people could start sending me pictures of the characters they want to rig and specific ideas they have for how to control them, stuff like that. You can also buy my personal component pack on Gumroad, but here's a list of all the different components that it comes with. A lot of these are human-like body parts, like arms and legs, spine, hands. There's also a lot of simple reusable stuff, like a negate inheritance node and a helper joint keep volume node, stuff like that. That's super useful in setting up a rig, and we'll talk about that at some point in the future. But if you can support me in those ways, it will really help me to make these tutorials, because I'll be able to afford to spend more of my time on this instead of on other things. So we're going to be building these reusable components over the course of the tutorials, but we're also going to be doing it in a sort of a simulated production environment, so that we can encounter and then deal with the problems we're going to face in production to show how Mantis is really very, very helpful. So let's go ahead and take a look at a sample character that I'm going to be working with here. This guy. I've gone ahead and made this simple mech in like an hour and a half. That's embarrassing. Looks like my Blender crashed. My materials are too powerful. Yeah, so I've got this simple mech that I made that's got this crappy material that I threw together in Substance Painter in like 10 minutes. And we're going to be rigging this mech for our next video. And right off the bat, you can kind of see that if I try to create a Rigify skeleton for this, it's not going to work, because this is not a human foot, and these are not human arms. And in order to rig this with Rigify, we're going to have to customize it so much that it's not going to be worth it in the end. So that's a little teaser for next time. And that's the first tutorial. Thank you for sticking with us. So, cool. All right. Thank you. See ya.